Hello class, Dr. Mike here for some more Python, specifically with week 5, topic 5, which we get into lists, dictionaries. Again, a lot of topics here, very important week. This is kind of a slice of that, and this is going to be on tuples and lists. So tuples themselves, again, the textbook, which is embedded, has a lot of information, more than we'll show you here. And there's a lot of information about tuples and dictionaries of tuples and so on. So I definitely suggest look at the videos and the textbook to get more in depth. I just want to just go over what a tuple is real quick. So first off, a tuple is could be any type of any value stored. They are indexed by integers, and again, indexing always starts with 0. The important thing is this: they're immutable. They cannot be changed. So why use this? Why have a tuple? Well, first thing, of course, is you think, well, it's data integrity, right? You basically don't want, you have a list of items you don't want to ever have changed. It makes sense to use a tuple. But also, if this is a very large list, a very large tuple, it actually is better in terms of memory use. There's less memory mapping going on with lists and so on. So tuples use less memory. So we'll get a quick look at them here. How you create a tuple itself. In this case, I have a tuple called T with a comma separated list here, and you can see I have both letters, characters, and so on. So open and close parentheses there, and if I do T, I get dumped out, and of course if I print the type, it's going to tell me it's a tuple. So if I'm not sure what T is, if I have really bad variable naming, which in case I have here, I can again use our type function, and I print that as it's a tuple. So what can we do with tuples here? Again, we have a few tuples here. This tuple itself, we can print the type within a tuple. In this case, nt here, which is, these are of course strings, and this is also a string. So keep that in mind when dealing with tuples. Always, if you plan to do anything with a value taken from a tuple, you definitely want to check and see what type it is. So I can't multiply, the value 2 by a number I have inputted when it comes across as, of course, string. So just verify anytime you pull anything from a list or a tuple. You should always verify. You can just do typecast or just do a quick verify somewhere in your notebook that you're dealing with the right value. Again, most of them you'll get an error. Again, you have list operators here though too. So again, we'll see list operators coming up here. This might be reverse of what the textbook shows you. I think they show tuples later. A list operator is basically saying, show me what item 2 is. So I go back to T, item 0, 1, 2. So remember we start at 0. And so I can pull item number 2. I can get a slice. So I can say, give me 2 and 4. So 2, 3, 4. So I got C, and I have number one. And again, biggest thing here, if I try this, you'll get this error, and this is normal. It's a tuple object. I'm trying to set item 0 to Z. So set T0 to Z. Tuple object does not support this assignment. Again, tuples are not modifiable. So keep that in mind. Again, look at the text for this. Tuples are definitely handy though for a lot of reasons. And that's chapter 10 under the current text of this value here. Then we're going to jump on to chapter 8, which are lists. So lists basically are immutable. It's a series of sequences, string values, characters here. So we can have an empty list. And you saw by tuples here, it's an important distinction. The tuple, when I open and close, when I start a tuple, was the parentheses here, open and close. Whereas a list, I'm using the brackets. So it's minor thing there to look at, but always look at the syntax. And in my list here is comma separated. I have a little one called cheeses. Oh, Gouda, I love Gouda. Nums, and then I have empty ones here too. So I believe I have a video either I'm going to create or will be created here that shows you how you can sort of parse a file and you can actually add to an empty list. I can create an empty list and add to it. Again, if I print type nums, it's going to tell me it's a list. I can call variable items. In this case, I can do print cheeses. Again, I can call item 0, which would be what? Should be cheddar. One of my favorites also. I just like sharp cheddar too. And again, I can print the numbers out here, print nums. Again, I can change stuff here too. So I can say nums1 equals 5. So right now, nums1 should be 3, 4, 6. And I change it to 5. Don't forget, we always start at 0. So 42 remains. Now the biggest thing, of course, is you can search through a list, parse through a list, and ways to do that, of course, is with a for loop. So, example here, I have 4. In this case, I have, let me pull my script a little bit here. Close that. So, for sheds and cheese, this could be for I, for X, for foo, you name it. But we do a for loop here for some value in my list name. And then if we your colon at the end here, and it's going to go through, and I'm going to go and create a loop. So I can hit enter. I can just print out every item, print sheds, or I can do if statements. If sheds is equal to Gouda, print yay Gouda. Else, just print cheese. So if else statements, again, you notice here the if, the condition, and then using 2 equals. So is it equal to? Make sure you keep that syntax in mind. Equals means to say, create, make this equal to this, whereas this is a comparison. If this is equal to this, so in this case Gouda, colon, enter, and you can see it automatically put the bracket there for me. The indentation. Print yay Gouda, enter, and I think I had to do a backspace manually, backspace 1, and then again else. Print cheese. So if this is a basic if then else statement, it's called. I'm getting a little bit into the logic side, but it's hard not to get into all of it at once. And we're going to see for looping a lot. And you can see here cheddar and yeah, Gouda. Yeah, right. So our last Gouda one there. So basics of some lists there. Let's keep going here. I'm sorry. We have other methods too. So again, we can append to a list, and this is, again, as you saw before, if we do the list name dot and then hit tab, you'll get different items. So we can append to the list. In this case, I have one here called fishes, or fish, barracuda, cod, devil ray eel. I can print it out, and I can do fish dot append. So if I type in fish, hit dot, hit tab, and Jupyter Notebook, you'll get a little drop pop out, and you can see all the list methods you can use. Again, these methods are basically functions in the list library, and again, we can append an item founder. So I do this. You can see here we have the print. Let's get out the marker here. We have fish here. Here we printed fish out. Again, print a function. It prints out list of fish here. Here we appended flounder. And there it is, it's been appended. So I can insert in a certain part of the list. So append is going to go to the end of the list by default, but you can append to, in this case, the index number. So that's what these 2 items here are. So again, here we can say the index number and then what to append. In this case, go to item 0 and append item 0 with anchovy. And you can see it did maintain the rest of the list, which would be the barracuda, cod, devil ray eel, and flounder, all were maintained. So it didn't overwrite 0, it kept it. So that's the case you need to have a special ordered list. You can do that. You can combine more than one list. So you have one called more fish, and I can do called extending. So I can extend a list to another list. If I run it, we'll go through the code here. So yeah, again, it's more fish. with all the names. Print more fish. I printed it out so you can see it here. And I print fish out. And then I did a fish.extend. So again, this is a list method. So fish, your list name dot tab, you'll see extend come up. And I need to put in the list to add to it. You can see it picked up at the very end here, and it added in more fish. Pretty handy way again for list handling in case you have multiple lists. You can remove items with the dot remove. We can remove on different ways. In this case, we actually remove on the name itself. So you can see here, fish, we remove kissing. Has been removed. So we took kissing out, which is remove and then that. So pretty straightforward. Fish.remove, removed kissing. And we can use something called the pop. We can return an item from it from an actual position itself. So position 3, so we should get cod back here. Sorry, devil ray. We removed facing. So 0, 1, 2, 3. Count from 0, Mike. So again, so item 0, 1, 2, 3. That's what the 3 there refers to. So we can pull an item from based on the index number. So this is, if you're not sure what is in, what is in the, in that position. You want to see what it is. Maybe you need to reorder your list. And there's ways to do that. We can do list indexing. You can use the index. So index for eel and index of cod. So eel, so there's 3, 0, 1, 2, 3, and cod being 2, 0, 1, 2. So 0, 1, 2, 3, 0, 1, 2. So again, you can ask where they're at by asking for the index. We can manipulate them also. A lot of ways also is to do a list copy. So maybe I want to maintain the original list. The reason why you would do this is, and you'll see this a lot, I recommend this beyond this list, even with files or even entire data sets. Unless the data set is enormous in size where you're limited by memory and or disk. A lot of times I want to maintain the original inputted list, let's say. Maybe I read it in from a file. So I'll make a copy of it and then maybe do some manipulation. I can compare them both then. So we can use the .copy. So in this case, as you saw, I made fish2 a copy of fish. So, and I guess we also have some other list actions we can take, like reverse list. So you can reverse listing. We can sort a list here. So you have fish.ages, and you can see this list here is not sorted numerically. Sorting again, I can print it out. You see it's been sorted. And then when we're done, we can clear out a list with .clear. So in this case, now it's empty. So this is some of the basics of list management. There's a lot to lists, but really adding to a list, sorting a list, copying lists, some basic stuff we can do. Again, lists can be appended to. I can change items in a list, whereas items in a tuple cannot be changed. So keep that in mind. Again, refer to the full lecture material and refer to the documentation again for full information about transversing lists, slicing lists, which also is a good one here too. There's a lot of ways, and all the list methods, deleting, listing functions, and so on. So again, that's a quick look at lists and tuples. Thank you.